Hey again, we're back with a part 3 of our review of volume and surface area. So let's just dive right in. We've covered all the way through question 12. Let's get to number 13. Campbell Soup is creating a new soup label, and if a can has a height of 6 inches and a diameter of 4 inches, how much material does she need for each soup label? Well, remember, we're doing soup label. We're covering the can. Covering the can means surface area. Not doing the top and bottom because cans don't usually do that. So that means we, for our problem, do lateral surface area of cylinder. Okay, and then from there we know the formula we need is 2 pi r h. It says our diameter is 4, our height is 6, so our solution would be 2 times pi times 2 because our diameter is our radius is 2 and our height is 6. So if we multiply that all out in our calculator, that's going to give us 2 times pi, okay, times 2 times 6. Our total or lateral surface area is going to be 75 to the nearest tenth 4 inches squared or square inches. And that's for one can. Okay? On to number 14. And reminder, what we're doing with these word problems is we're finding what the problem is. What are they asking? What formula do we need? And lastly, let's use our formula with the values that are in the problem and then solve. Okay? Number 14. Jacob is buying cups for his frozen yogurt business. He can choose from the cups shown. He wants to buy the shape that will hold more frozen yogurt. So which cup should he use? Justify your answer. If these were the same dimensions, we would go with the cylinder because a cylinder is got 3 times the volume of a cone. But if you notice, the height is bigger on this one, the height is smaller on this one, the radius is smaller on this one than this one. So it looks like it may be bigger, but the only way to find out is to prove. So we know we need to find volume of cone and volume of cylinder. So first we're going to do, the formulas we need are 1/3 pi r squared h, and we also need pi r squared h. So this one is for the cone, this one's for the cylinder. So we're going to just plug our values in and then get our solutions. So for number 1, or the cylinder, we're going to do pi times the radius, which is 1.5 squared, okay, times 4. And then for the cone, we're going to do 1/3 times pi, okay, times 2 squared times 6. So we have our values that we're going to plug in our calculator. Now we're just going to solve and see which one is the larger value, which one holds more. So the first one we have pi times 1.5 squared times 4. So the volume for that one is going to be 28.3 inches cubed, or cubic inches. And then the other one is going to be 1/3. Okay, we're going to pi 2 squared times 6. This is going to be 25.1. Yeah, 25.1 inches cubed. So we can clearly see that the larger one is going to be the cylinder. So this one is going to be bigger. It holds more volume. Okay? So this is the one that I would choose. All right, on to the next one. We're almost done with our review. So number 15. Jolly Time Candy Company sells their candy in 2 different containers. If they sell the cone-shaped container for $3.25, and they want to sell the cylinder-shaped container for the same price per square centimeter, how much should the cylinder-shaped container cost? I think there's a typo here, and it should be per cubic centimeter because we're talking volume here. And the relationship between a cone and a cylinder is that V equals 1/3 PH, whereas V equals BH. So if it's the same price per square centimeter with the same dimensions, then that means that this price will be 3 times as much as this. Okay, so that means that this price should be, let's write it like this: price should be equal to $3.25 times 3. Okay, because the volume is 3 times more than this one. So that means 325 times 3 is equal to $9.75. So that's how much our price should cost. If we needed to do the math to prove it, you would just plug in our radius so you can see the value. We would multiply our square foot, our cubic centimeters by the price, right? And then we would see what would go from there. But basically, all you need to know is the ratio between these two is that the cylinder is 3 times larger than the cone. Okay, last one. Number 16. Coca-Cola in a 12-ounce can has a height of 4.5 inches and a diameter of 2.5 inches. How much soda is in a 6-pack of Coke? So if we were talking about like ounces, obviously you would just multiply by 6 and you would have 72 ounces. But what we're actually asking for is the volume that the can actually holds in cubic inches. So volume in inches cubed. Okay, that's what we're looking at. So our formula is going to be IR squared times height, and then we multiply that by 6 because we have a 6-pack of soda, right? So our formula is this. We're going to plug in our values to say pi times, our radius is 1.25, okay, squared, times a height of 4.5 inches. Multiply this all out, we'll get our solution for 1 can. So that's going to be pi, once again, times 1.25 squared, okay, times 4.5. That gives us a volume of 22.1 inches cubed for 1 can. So how much for 6 cans? That means we multiply our solution by 6, so times 6. It gives us V, we're going to do 6V, because that tells me 6 volumes or 6 cans is equal to 132.5 cubic inches, and this is for 6 cans. All right, so that wraps up our review of volume and surface area of prisms, cones, cylinders, and spheres. Hopefully this was helpful for you. There was 3 parts, so make sure you watch all 3 to get the full review. Be sure to like, comment, share, subscribe, all of that stuff. Be on the lookout for more content as the rest of this year goes. And until next time, thanks everyone.